Okay, so this lesson is going to be talking about domain and range. So a relation is a set of ordered pairs which will create lines and different functions. Okay, so remember our ordered pairs always go x and then y. Domain is always my x coordinates. Okay, so these are x coordinates on a graph, which means range is going to be all my y coordinates. So these would be the y coordinates of the relation example that I just showed. So domain, range. Okay, for a relation to be a function, its domain can only be paired with one element of the range, so your x's cannot repeat. So we call this the vertical line test on a graph. Okay, so this would be a function. My x values never repeat. Okay, this would be a function. My x values never repeat. Okay, if I did something like this, my x values would repeat, and which would not it would cross my vertical line twice, which would mean it's not a function. So if you were looking at your set of tables, you would want to make sure those x's don't repeat for it to be a function. You never want to repeat your x. Okay, set builder notation, interval notation. Okay, so are commonly used to represent a set of numbers, therefore can be used to represent domain and range of a function, so from going left to right and top to bottom. So the most common ones you're going to see are going to be these ones here now. Okay, in interval notation, a bracket is used as an indicate an endpoint or a closed dot or something that it is running into that is included in the solution set. Okay, so this 5 here is a bracket, which means it would be a closed dot or going through that point. A set of parentheses indicates that it's an endpoint is not included in the solution set. So it is either an open dot, it is going very, very close to that number, or it's an infinity sign. Okay, my infinity signs. Okay, so if I had something that looked like this, infinity means it's going forever and ever a certain direction. So this would be forever and ever a certain direction. If we were talking about domain, it would be going forever and ever negative. Okay, this would be negative infinity in my domain because it's all my x's. If I kept going to the right forever and ever, that would be my positive infinity. If I was talking about my range or my y's, up would be positive infinity if I kept going forever and ever, and down is negative infinity if I kept going forever and ever. Okay, given each relation, state the domain and range and whether or not it's a function. Okay, so domain is x, range is y. So what is happening to the furthest, remember x is left to right. Okay, so what is happening to the furthest to my left? It is going from negative infinity. Furthest to my right, it never ends, it never stops, so it's going to positive infinity. Another way that you can rewrite this is this r, which means all real numbers. Okay, now if I look at my range, the furthest down that it goes, well, it keeps going down forever and ever, so it never ends. So negative infinity. It also goes up forever and ever, so positive infinity. It doesn't hit any walls or it doesn't curve anywhere. So again, we have all real numbers. If it's a function, it would have to pass the vertical line test. So it looks like if I drew a bunch of vertical lines, it would pass. My x doesn't repeat, so yes, it's a function. Okay, my next one here, it looks like it's going down to negative infinity and up pretty to positive infinity. When I say pretty, I mean it's increasing by the same thing. It's also decreasing by the same thing, in which case the -1. So to double check what it's going to look like, I would suggest graphing it. So my first one is -1 and then like 18, so way up there. 0, 11, 1, 6. Then we got 2, 3. So we're just going down, down. And then this 4 goes back up. So it's actually going back up, sorry, I ran out of space there, and looks like this. So if you graph it, it is actually a U shape. So my domain, which is all my x's, the furthest left that it's going to go is negative infinity because it continues forever and ever, and it also continues forever and ever to the right, so positive infinity are all real numbers. The range is a little tricky in this one, so we need to figure out where that U is hitting in here. So if you draw a better graph, you'll be able to see where that U is hitting. So I'm going to pause, I'm going to draw a better graph to see where the lowest it goes. Actually, the lowest it goes on my y values is 2, so that's where it's going to hit at. So we're going to use a bracket because that's the lowest it'll go, and then it's shooting off to positive infinity. Okay, and then infinities are always parentheses. So then we double check to make sure our x values don't repeat, so I just look at this column and they don't, so it's going to pass my vertical line test. Okay, here's my next set. my domain is the furthest left that it goes, so it goes to -5, and it is a closed dot, so I'm going to do a bracket. The furthest right that it goes is a +5, and it's an open dot, so we're going to do a parenthesis. The furthest down that it goes, because remember range is y, it starts at -2 from the bottom, and it's a closed dot, so we need a bracket, and the highest it's going is 7, and it's hitting that 7, so we need another bracket. And it looks like it's going to pass my vertical line test. There's no jumping occurring. Okay, my next one here, it's kind of all over the place. So let's go ahead and graph it so we can figure out what's actually happening. So I have an idea of where I'm going. So I have 2, -2. I have -1, -1. I have -2, 0. I have -1, +1. And then I also have 2, 2. Need to fix that 2, 2. It was a little far over. All right, so I automatically see I have my 2 repeating here, so it's not going to be a function. Okay, so if we were to draw it, it looks like this right now. So the domain is going to be from -infinity to +infinity, if I can write. My range, it looks like the lowest that it's going to go is -2, and it's including it, and the highest it goes is +infinity. Okay, my next one here, my domain, it looks like from left it goes all the way to -infinity. From my right it keeps going to +infinity. There's no holes. My range, the lowest it's going is 1, and it's hitting at 1, so it's a bracket, and it keeps going up to +infinity. There are no, when I do the vertical line test, it doesn't cross twice, so I should be good there. My next one, it goes all the way to the left and all the way to the right, so we're doing -infinity to infinity, or all real numbers again. My range, it starts at 3, but it's an open dot, and it goes up to +infinity, and it is a function. Okay, because it passes my vertical line test, because those are not 2 closed dots, because one's included and the one isn't included. Okay, so to double check again, we're going to go ahead and draw. So -3.04, -2 a little higher, -1 a little higher, 0, 1. So it looks like we're going off. It doesn't show any negative values, so I'm going to assume that there are none. Okay, so it looks like we're going all the way left and all the way right. So we got infinities again, or all real number. My range, though, is going to be 0. It's getting closer and closer to 0, but not hitting it, and it's going to shoot off to +infinity. Okay, my x values don't repeat, so it is a function. My next one, my x's repeat. It crosses my vertical line twice, so I already know this is going to be a no-go. Left to right, so the furthest left it goes is -2. The furthest right is 5. They're both included because they're closed dots. The furthest down it goes is -1. Furthest up it goes is 4. Okay, state the domain and range for each graph and state whether or not each represent a function. So it looks like they both pass the vertical line test, so they're both functions. My domain, it looks like it goes down forever to the left and all the way to the right, so we have all real numbers. My range, the furthest down it goes, well, since this keeps going and going, it goes -infinity, and since it keeps going up and up on the y, it's going to +infinity, or all real numbers again. Okay, if I just have plotted points, all I need is my x equals all of my x values, so -4, -2, 3, and 3, and then range would be all of my y values, so 5, 1, -2, and 4. And actually, my 3's repeated, so it is not a function. That should have been no. Okay, opposite domain and range. So the first step is always to label your axes. So this is my domain, which is my x, range is my y. So -3 and 10, and then -4 and 6. Okay, and then we find our pair. So a bracket, or something that would be a closed dot. So if I look at these, they're a bracket and it's also included. So that's going to make a point. So -3, -4, there's a closed dot. And then these ones also match because they're also both included. So at 10, 6, there's another point, and then we can just connect them. And it's a function because it passes my vertical line test. Okay, this is the hardest one that you'll ever deal with. You won't see this very often at all, but I'm going to show you what it is. So my domain is all real numbers, so it's going to go all the way left, all the way right, and it needs to hit at these y values. Okay, the lowest it's going to go is 2, so I need to start it off at 2, and then I need 4, 5, and 8, and it needs to be a function. Okay, so this is actually an interesting one because it's a stair step. So it's going to be a closed dot at all of these, but since it needs to pass my vertical line test, the next one up also has to be an open dot. And then I need a closed dot to be on there somewhere. So another open dot, a closed dot to be on there, an open dot, a closed dot to be on there, and it's going to shoot off to the right and to the left to get those x values. Okay, the reason that we have the closed dot is because I need to include those, but I also have an open dot so that when I do my vertical line test, it passes both of them. Okay, my next one, it goes from negative infinity to 5 on my x, and from negative infinity to negative 4. So that means the highest it goes is negative 4 on my y. The furthest to the right is going to go 5. So if it's a parenthesis, I know I need an open dot, and I need a closed dot somewhere on negative 4. Remember, the highest it can go is negative 4. The furthest right it can go is 5. So I'm just going to make a closed dot, and then I'm going to have it shoot off down because it needs to go to negative infinity. Sorry, that should have been a down arrow. Okay, because the highest it can go is negative 4, the furthest right it can go is 5. And then 5 is not included, so open dot, negative 4 is included, so that's why we did the closed dot and we're shooting it down.